Hello students. Next we will see proofs. We have studied many properties of angles, triangles and quadrilaterals through activities in the previous class. In this standard we are going to look at the subject of geometry with a different point of view, which are originated by the Greek mathematician Euclid, who lived in the 3rd century before Christian era. He gathered the knowledge of geometry prevailing at his time and streamlined in it. He took for granted some of the self-evident geometrical statements. Okay, now let us see what are proofs which are laid down by the Greek mathematicians Euclid. The first one is postulates. Self-evident geometrical statements which are accepted by all are called postulates. Now what are these postulates? That they are the statement with the self-evident. Nobody can prove them. They are with the originated, they have their own property. And they are self-evident geometrical statements. They are called postulates. The next one is theorems. Now what are theorems? Properties proved logically are called theorems. Now theorems are the properties of triangles, properties of quadrilaterals which are being proved logically using this Euclid or using these postulates is called theorems. Now let us see Euclid's postulates, what he has laid down one by one. The first one is there are infinite lines passing through a point. Means from one point infinite lines can pass. Now see here, I have given you one example here in this image, that O is this one point, and from this O point infinite lines can pass through this one point. The second postulate is there is one and only one line passing through 2 points. When there are 2 points, only one line can pass through that 2 points. And if you are trying to pass the other line, that will be the same line only. It cannot be a new line. So there is one and only one line passing through 2 points. The third point is a circle of given radius can be drawn taking any point as its center. Means suppose if you have to draw a circle of 3 centimeter, you can take center anywhere on the plane. It's not compulsory that it should be in the right, left, here and there, nothing. It can be taken any point and that point will be the center of that circle. A circle of given radius can be drawn taking any point as its center. Means any points, like if there are 3-4 points on the plane, you can take any point and you can draw a circle. The fourth one is all right angles are congruent to each other. Very important property or very important postulate which we use again and again in our near future. Now all right angles are congruent with each other means what? In spite of their length of their arms. Whether the arm is very long or whether the arm is very short. But if the degree is 90 degree, all right angles are congruent with each other. See here, I have shown you few figures here. Few angles are shown here with different directions. But the angle is same. That is why all right angles are congruent to each other. And the last one is if two interior angles formed on one side of a transversal of two lines add up to less than 2 right angles, then the line produced in that direction intersects each other. Now here there are 2 parallel lines or the 2 lines are there and there is one transversal passing through it. In 8th standard you would have seen parallel lines and transversal. Okay. Now if the 2 interior angles formed on one side of a transversal of 2 lines add up to less than 2 right angles. Now what is the sum of 2 right angles? 90 plus 90, 180 degree. Means if the 2 interior angles are less than 180 degree, then the line produced in that direction intersect each other. Means if the interior angles formed on the one side of a transversal is less than 180 degree, the sum of that 2 angle is less than 1 degree, then somewhere they will intersect each other. This is the postulate laid down by the Euclids. Now the next one we'll see proofs. Now what are proofs? A property is supposed to be true if it can be proved logically, and that's why it is called theorems. A property, now that property may be of a triangle, of a quadrilateral or an angle. If it can be proved logically, then only it is called as theorem. The logical argument Now we have to make your argument, or we have to write here something, no, to prove that it is a theorem. The logical argument made to prove a theorem is called its proof. Means we have to give proofs. Let me tell you, geometry is very scientific subject. We don't believe anything blindly. We search for proofs. If it is a square, all sides are congruent, all angles are 90 degree, diagonals are congruent. We search for proofs and then only we believe on them. So in the same way, in geometry, proofs are very important. Now in our next session, I will show you how to write proofs. Thank you.